So, good afternoon, one and all present here. Today we will discuss about wireless communication. So, I am Muhammad Abbas from BS and one of my colleagues is accompanied with me, and he is R. Venkadeswaran. So, both are working in Department of Computer Applications in BS University. Okay. So, today, we will see the types of communications. There are two types of network communications. One is a wired communication, another one is a wireless communications. In the case of wireless now let us see what is wired, what is wireless. So suppose the systems are connected or any two devices connected with any physical medium, that is for example any wire is connected between the two medium, that is we named as wired communications. So another type of communication, wireless communications, any two machines or any more than two machines are connected without any physical mediums, we named as that is a wireless communications. So today lecture we will see what is wireless communication, what are the types of wireless communication, and from the wireless communication we will see only one that is a wireless communication protocol, right? So this is the picture is shown that. So that suppose one source wants to communicate with the destination, so it will send the communication through intermediate nodes. This is a skeleton of the communication between source and destination without wire. So now let us start the introduction. So you are transferring the communication from source to destination. So that's we named as in the technique we named as routing. So what is the routing? Routing is nothing but the packet the moving a packet from source to destination. Source to destination, who is takes the responsibility of route the packet from one place to another place, that is called router, right? So in our regular we are using in our LAN network. So the device is the switch, and switch is there. The switch is take the part of to route the packet from one lab to another lab. This normally we are doing that. But in this wireless communication here, so each and every node act as a router. The person is responsible for transferring the content or packet from data or one place to another place. In the one place to another place, so one node to another node. This is the meaning of the routing. So in the routing, and here suppose in that wireless communication, definitely we need one routing table. So what is the routing table? In the routing table only, routing table only have the information about who is a source and who is a destination, and what are all the things between the source and destination, how your packets are transferred. All the contents are available in that routing table. So we need routing table. So what all the informations are included in that routing table? Destination, it will have the destination IP address, and it will have the what is the next hop. What is the, suppose one node, suppose for example the 10 nodes are there. So I am the second node, the next person the third node. Now I am transferring the content, I must know who is the next person. So the next person, that is called next hop information, it must need it. So next one is the interface. Then interface is nothing but what is the outgoing, that is called who are, that is suppose you are packeting the information from one node to another node. So the outgoing network information device should be used when forwarding the packet to the next hop for the final destination. So without the interface we are not able to transfer the content from one node to another node. And another type of information in that routing table, that is a metric. And in the metric, it's a most cost effective path can be chosen for the transfer, because shortest path, we need shortest path to transfer the information one place to another place. The next one is the routes. So routes in the sense, probably you can directly communicate. Suppose there is no in between the node, you can directly communicate the one node to this next node will be the your destination node. You can directly communicate. Suppose your destination is far away from the source node, so between the some nodes will be there. So we will name it as sub nodes. So when the source node send the communications to the next hop, the next node will receive the information. Again it will pass the information to the next node. So that is color. So here, so includes directly attached the subnode, indirect subnode that are not attached to the device but can access through the one or more hop. That's a very more. So And suppose what is the use of this subnode? Suppose any link break occur in that between the path, so the subnodes are useful for the re-establishment of the route. So we need routing. These are the informations available in the routing table. So next we will move to the what are the classifications of routing protocol. So already we know that the protocol is nothing but there is set of rules and regulations. Suppose we are transferring the content from one place to another place, we must follow some set of rules. So based on this set of rules and there are four categories of the in the wireless communications. The first one is the route information update mechanism. Another is use of temporal information for routing. Then third one is the routing topology, and the fourth category is the utilization of specific resources. In the first one is the routing the first information, that is a routing information update mechanism. The routing information update mechanism, there are three types of routing protocols using in the routing information mechanism. The first one is a proactive or table driven routing protocol. The second is a reactive or on demand routing protocol. The third one is a hybrid routing protocol. The proactive table driven routing protocol, here each and every node movement, all the informations are stored in the table, right? Is there any changes? Simply it will the node is moved from one place to another place, immediately it will reflected in that table. So it will maintain the entire topology informations about the table. So second is a reactive on demand one. So in this routing protocol, so on demand basis only it will establish the communications. It will not, suppose I want to communicate with the next person, then a route establish will occur. So what is the advantages of on demand routing protocol? Suppose whenever the route path is required, then only it route establish. What is the advantages of this table driven? It will maintain the whole network topology information. Then whole network topology informations only. Then so another, this is the disadvantages of the table, because and is there any changes in it will change the entire topology. So it will occupy so much of memory space in the table driven, but and compared to on demand. Then third routing protocol, there is hybrid routing protocol. In the hybrid routing protocol is combination of both. So certain zone, so we compare to some region it will work for the proactive, some region it will go for the, that is on demand, but there is a reactive routing protocol. So is there there is no nodes in between the some portion, so it will go for protocol. This is a combination of proactive and reactive. So this is then what is the second category of our wireless communication? There is a based on the use of temporal information. The temporal information is nothing but, and what is the position, that is a temporal in this, that is a geographical position information status of this. So there are two types of, one is called routing protocol using past temporal information, and routing protocol used for the future temporal. So what are that already informations are available based on the already existed path, it will go for the routing the information. And the second one, this is a future temporal. So it will forecast see what is the next node and what next node will be entered into the region. So based on the forecast information, it will do the information. There are two types of. What is the third category of that is based on routing topology, and is based on the topology information. There are two kinds of topology. One is a flat topology and is hierarchical. Flat topology in that is all your horizontal topology, and the hierarchical topology, that this is a vertical topology. In the horizontal topology, so it will so all the nodes are the equal priority, and hierarchical topology, that is a hierarchical topology, probably and it will give the information from the above nodes. That is the third category. What is the fourth category? There is utilization of the specific resources, that is called power aware routing, and that is a geography information assisted routing. So power aware routing, based on the battery power, it will have the route establishment. Another one is a geographical information, that is called, it will know, it will need the full information about that is a geographical position of the information. So then only it will have the coordinates. Based on the coordinate, it will establish the communication. So there are four category of the classifications of a network, that is a wireless communication. From the categories, in this class I will going to handle only one routing protocol, that is called on demand based routing protocol, that is called a reactive based routing protocol. The reactive based routing protocol, on demand basis only it will establish a communication, right? So it established. So AODV is a very famous routing protocol, that on-demand ad hoc on-demand distance vector routing protocol. So it will on-demand distance or on-demand basis only it will finding the routes. So another the similar way of AOD, one more routing protocol, DSR, that is dynamic source routing protocol. The dynamic source routing, what is the major difference between these two, DSR and AODV? And DSR, and it will source routing in which the data packets carries a complete path to be traversed. It will have the complete from source started the initiation, it will finally reach a destination, and it will have the complete path to be traversed from source to destination. But in the AODV, it will not maintain the any full path information, it will maintain only the next hop information. So it will not maintain the entire path. So so that, and compared to DSI, AODV is a better one. No need to maintain the entire path. Suppose any link break occurs between, and easily we can retrieve the problem for the link break in AODV. This is a major difference between the, and another what is the difference between AODV and on-demand distance one, and it will maintain the destination sequence number. So when updation of destination sequence number, easily we can identify where is the destination. So the based on the direction of the destination, we will reach to the destination. This is a major advantage of the AOD. So, and what all that, so suppose the source node wants to establish the communication to the destination. So what are the content will be there in that route request message? The source ID will be there, and destination ID is there, and source sequence number, destination sequence number, and broadcast identifiers, and TTL number. The TTL is there is a time to live. So time to live in the sense, what are the time taken for the source to message reach to the destination. So the TTL is very most important. So within a stipulated time period, the route is established to the source destination, and the reply should come to the source. Suppose the time is exists, and the route the source will identify the route is failure. So there is a very most, these are all the most important parameters available in the source route mechanism. So once your source send the request to the destination, it will reach to the, either it directly reach to the destination, or in between the nodes through the next hop, it will reach the destination. So once the source route request message is reached to the destination, and immediately your destination will send the route reply to the source through the traversed path. So traversed path is, so in the routing table maintain the traversed path, how your source route request message reach to the destination. Once a reply message is received by our source, then only your data that is the data packet are transferred to the destination. And this is a very most important for the route reply message. So route reply message only decide that whether the route is established or not between the source and the destination. So this is the route establishment of the AODV. Here I have only the 50 nodes. There's one is a source node and 15 is a destination node. And the source node simply send the route. There is a broadcast the route request message, and first it reaches the second node and the fifth node and sixth node. And these are all the route, that is called this line. This line is showing that there is a route request message, and the route request message reaches the several ways reach to the your destination node. And once the destination receive the route request message, it will forward the content to, that is a route reply message to the source node. There is a dotted arrow mark showing that route reply message. Here the two paths are established. One path is 1, 5, 10, 14 and 15, and another path is 1, 5, 4, 12 and 15. There are two paths as established. So from the two paths we will select any one of them, that is a very shortest path, will take it to the consideration of the route establishment. Suppose in future is there any link break occurred between the any two paths? For example, here the in between fifth node and fourth node the link break is occurred. So that, and immediately, so route error message, that is this route error message initiated by the node, and so the route error message forwarded to the source node, and source node identify the link break occur between the particular node. So the source node again reinitiate the root establishment within the source node. So this is the local root repair mechanisms not available and not possible in the AODV protocol. This is one of the disadvantages of the AODV protocol. So the again source node reinitiate the entire route to the destination node. And here, so already I informed that AOD does not repair of the locally, and it will repair, it will start from the scratch, that is from the source node. Suppose when the path break, for example, for node 4 node 5, both the nodes sends a root error message to inform their end node about the link break. So end node delete the corresponding entries from the node, so it will again break as a reinitiate the node. So what are the advantages and disadvantages? And the source nodes are established on demand, and destination sequence number used to find the latest route to the destination, and a connection setup is lower because, and based on the sequence number, and it will identify the next hop and easily so that the connection delay is very less. What are the major disadvantages? This is in this AOD routing protocol, and there is local repair mechanisms not available in that AODV, and it will send the informations to the source, and the source again reinitiate. So the multiple requests or multiple replay packets are generated in that path, so that it will increase overhead in that establishment of route. And that is AODV is that periodic beacon leads to unnecessary bandwidth consumption in that AODV protocol. So this is one of the very famous AODV routing protocol. So much the research work is also going in that AODV routing based on the AODV routing protocol, and in the adaptive AODV some of the best one, but some of the disadvantages in the AODV we will rectify it, and it will establish route between the source and the destination. Thank you. Good afternoon. 100% here. Good luck.